Hi guys, here is your lesson for inverse trig functions. So we'll cover inverse trig in this video for sine, cosine, and tangent. So we'll cover all three in this video. So it may be a little longer than our videos are normally. We have quite a few slides to work through, and we'll sort of start here with a little refresher about what the word inverse means. So, as you read through this, a recap from Algebra 2, just a few facts about these inverse functions. They reflect over the line y equals x, so that diagonal line. The x and the y values are swapped. So as we think about x and y values, when we talk about these trig functions, when we talk about x's as inputs and y's as outputs, remember for these trig functions that my inputs are angles and my outputs are either x values or y values or a ratio of the two. So my outputs, remember, those x values and y values represent side lengths. So when we swap these things, we're talking about taking an inverse function and putting in side length values and getting out angle values. So lastly, a function needs to be a one-to-one function in order to have an inverse function. So unless we restrict the domain. So this will make a little bit more sense as we sort of move through. But right now, our sine, cosine, and tangent functions are not one-to-one functions. So we want to sort of treat them like they are one-to-one functions. And in order to do that, when we talk about the inverse, we're just looking at sort of a snapshot of the domain. So what do I mean by that? So are sine, cosine, and tangent one-to-one functions? They are not right now at least. So in order to talk about their inverses, we need to restrict the domain. So what I mean by that is if you think about what a parabola looks like, here I have the graph of y equals x squared, or f of x is equal to x squared. If I wanted to talk about the inverse function of a parabola, I would talk about it, but I would really only refer to this piece of my parabola, so that when I take the inverse, and we'll do it in another color, that my square root is also a function. So the inverse of x squared is the square root of x. But when we talk about it as a function, we're only talking about these positive values, and we're not really referring to these negative values that are down here. So we're doing something sort of similar with sine, cosine, and tangent. And to make it really tricky, we're not using the same domain for each of them. So when we talk about the inverse of sine, so here's a graph of sine, we can clearly see, using my horizontal line test, that this is not a one-to-one function. So what we're going to do is we're going to restrict the domain, and we're only going to talk about this between negative pi over 2 and pi over 2. So when we talk about this inverse sine function, we're only really examining the values that are in between here. The other thing is when we talk about the domain and the range of these inverse functions, remember as we flip-flop the x and y values, my domain and my range are also flip-flopped. So thinking if this is regular sine of x, so for sine of x, my domain, let's say, is from negative pi over 2 to pi over 2. And my range is from negative 1 to 1. Well, for sine inverse of x, so y equals sine inverse of x, my domain becomes values from negative 1 to 1, and my range, this is really where we're sticking to the negative pi over 2 to pi over 2. So this will make a little bit more sense as we work through some of these problems. So let's sort of dive in a little bit here. So inverse sine, another way to talk about inverse functions is to call it arc sine. So these two things will be used interchangeably moving forward. So sine inverse and arc sine are the same thing, and they're both referring to the inverse of our sine function. So again, talking about this restricted domain, as we're looking here, and I'll sort of alter this unit circle, we're talking about negative pi over 2 to pi over 2. So instead of 5 pi over 3, we have negative pi over 3. Instead of 7 pi over 4, we have negative pi over 4. And 11 pi over 6, we have negative pi over 6. So we're going from negative pi over 2 to pi over 2. So this is the domain of my regular sine function, but these angles here will be the range or the outputs of where my sine inverse or my arc sine function exists. So let's work through some of these problems together. So sine inverse inputs side lengths and outputs angles. So this is talking about a side length, and my answer will be some kind of angle. Or another way to think about this is sine of some angle is equal to 1/2. And I'm only looking for this angle in between negative pi over 2 and pi over 2. I'm only examining this portion of my unit circle. So I know that my sine is referencing the y values in my unit circle, and I can see here that at pi over 6, my sine value is 1/2. So this angle that I'm looking for is here at pi over 6. And so this is the answer. So sine inverse of 1/2 is equal to pi over 6. Or I can say arc sine of 1/2 is equal to pi over 6. So moving forward, let's take a look at another example here. This is the same as saying sine of some angle is negative square root of 3 over 2. So I'm looking here. Here's where my sine value is negative square root of 3 over 2, and this is going to be equal to negative pi over 3. Because remember, we're talking about negative pi over 2. These are all become negative values. So because we're restricting that original sine domain to create an inverse that is a function. So here's another example. So I can also write this as arc sine of pi over 2 is equal to, so remember this is a side length, and I want to output an angle. While thinking about the domain and the range of my arc sine, pi over 2 is going to be a value that's greater than 1, and it's also a value that's representative of an angle. So this is outside of the domain, and this does not have a solution in the inverse function. There's no solution here. I could evaluate sine of pi over 2, thinking about what my inputs and my outputs are, but I cannot input an angle into an inverse function. I can only input side lengths and output angles. So looking here, sine inverse of sine of 5 pi over 6. So let's go ahead and evaluate what this would be first. So sine of 5 pi over 6 is going to be 1/2. So this is really like saying sine inverse of 1/2 is equal to what angle? And I know that I'm talking about pi over 6 here. So here my answer becomes pi over 6. If this was a value that was within our inverse domain, I know that the inverse and the sine would cancel each other out, and then I would just be left with what my input value is. But because 5 pi over 6 falls outside of the domain and range for my inverse function, we need to evaluate. So let's take a look at cosine. So like sine is being evaluated between negative pi over 2 and pi over 2. The restricted domain for cosine is from 0 to pi. So let's take a look here. For cosine, we have cosine inverse and we have arc cosine. Again, those will be used interchangeably. And we evaluate the inverse of cosine between 0 and pi. So this is the piece of my unit circle that we're looking at to evaluate here. So inverse cosine, cosine inverse of 1/2 is the same thing as saying arc cosine of 1/2 is equal to what angle? Or cosine of some angle is equal to 1/2. So I'm looking for when I have an x value of 1/2, and here I am at pi over 3 or 60 degrees. So this is equal to pi over 3. Looking here, cosine inverse of 1. So I'm looking for when my x coordinate or my side length is equal to 1. Remember, this is the same as cosine of some angle is equal to 1. And where is my x coordinate 1? That happens here at 0 radians or at 0 degrees. So here, this is equal to 0. And remember, this is 0 degrees or 0 radians, and it's in no way referring to the y coordinate of 0. Cosine inverse of 0, so I'm looking for what angle gives me an output or an x value of 0, and that looks like it happens here at pi over 2 or at 90 degrees. So cosine inverse of 0 happens at pi over 2. Cosine inverse square root of 3 over 2, so I'm looking for when my x coordinate is negative square root of 3 over 2. That happens here at 5 pi over 6 or 150 degrees. So my answer here is 5 pi over 6. Let's take a look at tangent, and remember that you can rewind, pause, fast forward, anything that you feel like you need to do. If you feel like this video or this lesson is moving a little quick, remember that you can pause and get some of this down. So when we talk about the inverse tangent, we use the same restricted domain that we used for sine. So cosine is the only one that has sort of its own special restricted domain. So here again on my unit circle, this is negative pi over 2, negative 5 pi over 3, negative 7 pi over 4, and negative pi over 6. So those are the values that we're using here. So arctan of pi over 3. So this means I'm looking for tangent of some angle where my output, that doesn't need to be a 1, where my output is the square root of 3 over 1. And so thinking about these coordinates and when that would happen, I know that my tangent, my regular y equals tan of x, happens when I divide my y values by my x values or my sine by my cosine. So looking at these values here, the way that I would create the square root of 3 is by looking at a coordinate point that was 1/2 square root of 3 over 2, because the square root of 3 over 2 divided by 1/2 is going to give me square root of 3 over 2 times 2 over 1, and I'm left with square root of 3. So my angle here that I'm looking for this coordinate point right here, 1/2 comma square root of 3 over 2, and that happens here at pi over 3 or at 60 degrees. So arctan of square root of 3 is going to happen at pi over 3 or at 60 degrees. So moving forward, inverse tan, again, I'm looking for when I'm dividing my y coordinate by my x coordinate, and I'm getting a value of 0. So here, that happens here at 0 and at 0. So this is referencing 0 degrees or 0 radians. Let's take a look here. Tan inverse, so again, tan of some angle is equal to negative square root of 3 over 1. So I'm looking for an angle that has coordinates of 1/2 square root of 3 over 2, and I want one of them to be negative, so looking in this domain, it looks like that happens here. So I'm looking at negative pi over 3. So that's the end of our video lesson for today for inverse functions. Sort of a really big takeaway is thinking about these restricted domains and how they affect what we call a function and what we call a non-function. Your homework is to go through and analyze some of these or solve some of these inverse trig problems. So make sure that as you're solving these, that sometimes it's really helpful to cover up the side of the unit circle that you're not using so that it really helps you move forward and focus on those specific domains.